Alright, this is topic 6.3, more inscribed angles and angles formed by secants and tangents. On the first one, we have, they want you to find the actual angle degree. So that means they're looking for this one. So if we knew the angle out here, we'd take half. It's always half when you have an intercepted arc. If they gave you 2 of the arc degrees already, you just, the way I would do it, I would just add 130 and 120, and that's 250, and then take 360 and subtract 250 to get the missing arc on the outside. So that would be 110. Let's go ahead and label that. So that means this arc, you can even put a little dotted line if you want, from here to here would be 110. If you want to check them, just add them all up again and make sure they add up to 180. So since it's a inscribed angle, it's always half. So if you take 110 and take half of that, that gives you 55. So that means the angle's 55 degrees. I'll write that on here too. Alright, on this one, see how they've marked on example 2 the tick marks on the chords? That means it's an equal, it's an isosceles triangle. So these would each have to be 50 degrees, because if you add 50 and 50, that's 100, and 100 plus 80. Anytime you have an isosceles triangle, the base angles are going to be equal. So they all add up to 180. Now all you do to get your, let's do x first. To get the degree for x, you're going to take 80 and double it. You're just doubling the angles. So, I meant to write an 8. So 80, that's an 8, times 2 is 160. To get the y, you're going to double the 50. So that's 100. To get the z, it's going to be the same. You're going to double 50. That's 100. So if you add them all up, make sure it adds up to 360. Looks like that one does. So these are your 3 answers. Alright, let's review this one. Example 3, the 2 angles that are given here are going to have to add up to make 90, because an inscribed angle, when it intercepts a semicircle, since the degree out here is 180 degrees, half of that is 90. So that means these 2 have to add, your 2 missing angles have to add up to equal 90 degrees. Let's see, 2x plus 2x is 4x, 1 minus 3 is negative 2. If you add 2 to both sides, you get 4x equals 92. Divide out the 4, x is 23. Sometimes I feel like I might go a little too fast. You can always pause it and copy down the steps if you need to. I just don't want to take too long. Let's review here on example 4. These angles, let's look at what we have. Alright, anytime they tick mark a chord like this, the angle, the arc measurement, they're going to be the same. So even though they didn't mark it on this paper, this arc that starts from this point to this point is 105. And if you add all of these up and subtract from 360, that's going to give you this, the missing arc right here. So let's do that real quick. You have 105, 75, and another 105. And you have to add something to that to equal 360. I'm just going to call it x. We'll call, you know what, I'm going to put the little dashed little lines here, and we'll call this x out here. So our x is going to be added with the other arcs to equal 360. If you add this up, you get 285, And if you subtract 285 from 360, you'll get 75. So that means this arc out here is a 75-degree angle. Now to get the two angles, if you look, they're both intercepting a 75. This X right here is 75 degrees. So to get angle 1 and angle 2, they're both the same. You're going to take, let's write that. Angle 1 has to equal angle 2 in this case because they intercept the same arc. They're equal and they're going to be half of 75. So just 75 times a half, and that's going to be 37.5 degrees. That's your answer. Number 5 is a review. If they give you the arc with a tangent and a secant, and it's sitting on, the vertex is on the circle, it's always half. So your X is going to be half 140. After you do these a while, it'll kind of get a little bit easier. You'll start remembering when to take half and when to keep it the same. Like on the next two, you're going to have to use the formula for circles where the angle right here is not in the center, so it's not half, it's not equal, it's half the sum. So you know that that angle, to get that angle, it's half the sum of the two. And let's work this out. Remember, to get an easy way to get rid of 1/2 is to double both sides. Let's go ahead and show that. I'm going to double this side and I'm going to double this side. So I get 160 is equal to X plus 110. If I subtract 110 on both sides, that leaves me with 50. So X is 50. That's because it's the different, half the sum. This one, the outside angle is half the difference. Now, this arc, we're going to have to figure out this little piece right here. I think I'm going to grab my colored pencil. We need, where these two secants hit, we need this arc right here, and we need this arc right here. So if you notice, they've hit a semicircle, and 110 and if you add 110 and 45, and then you have to add this little arc. I won't call it X. How about Y? I'll call it Y. You add Y to it. That's because it's a semicircle, it has to equal 180. So you're going to have to do that first. You're going to have to solve for that angle. Let's see. 110 plus 45 is 155. Yeah. So if you have 155 and you add it with Y, that equals 180. So if you subtract 155, you'll get 25. And we're going to need that little angle, because when you want an outside angle to get X, you're going to have to do half. And in this case, this one is an inside angle, so it's half the sum. This one's half the difference. So it's 45 minus 25. 45 minus 25 is 20. Half of 20 is 10. So that means X is 10 degrees. This is really your answer. They wanted you to find the value of X. Alright. Let's go on. The last example looks like they want a bunch of angles, and we're going to have to work through this one. I'm going to give you a few minutes to kind of look at it. There's lots of stuff going on. We are going to need some angles. AG is 100 degrees. Let's go ahead and label some of these things. So from here to here, you know, I think I'm going to use some colored pencils. AG, I'm going to color it up here orange, and I'm going to color it right here orange. Kind of make it a little colorful. That's 100. And CE is 30. I'm going to use a blue. That's 30 degrees. And EF, where's EF? EF is 25. I'm going to use a green to do that one. 25. Okay. Now what else do we know? I think that's it. Alright, angle 1 is a central angle. Now let's look at the things. We kind of need to look at what they gave us. Angle 1, if angle 2 is the central angle for, see how AOG is a central angle and angle 2 is intercepting 100, that means angle 2 is 100 degrees also. So I'm going to go ahead and fill that in. That's a central angle. These are a linear pair, so angle 1 has to be an 80 degree. They're on this diameter, so they both have to add up to, they have to be supplementary. Angle 3, we'll go in order. Where's angle 3? Okay, angle 3 is an inscribed angle that's really, if you need to put this one together, 30 and 25, that would make that 55. So half of 55 is 27.5. It's an intercepted arc, and it's half because it's on the circle. Angle 4 is inside the circle, and so it's going to be, you know what, we got to figure out some other arcs here. I have a red. Let's try red. This arc right here, the color red, has to be 80 degrees. Let me grab another colored pencil. How about yellow? This arc, I'm going to color it yellow, is going to have to be, now I'm going to have to write it in pen or you won't see it. This yellow arc that goes from A to C, because this is 55, this is going to be 125, because you have to add, make sure I'm doing my math right. Yeah, you have to add 30 and 25 to 125, and that's another semicircle, so that's 180. Now the reason I did all that, if you look at, to get angle 4, you're going to have to use, it's an inside angle, but you're going to have to use 80 and 125. I think I'm going to write that down here. It's half the sum, so it's 125 plus 80, and then you take half of that. Make sure I do my math right. Oh, you know what? It's not 125. Look where angle 4 hits. Angle 4 is using the little piece that's blue and the 125. So that's actually 155. Change that to 155. That's a 5. 155 plus 80. Let's try that. 155 plus 80. Take half of that. This one's a decimal. It's 117.5 degrees. And now angle 5 is just a linear pair with angle 4. So if you just take 180 and subtract that answer, you get 62.5. That's just a linear pair. For angle 6, that's an outside angle. That's going to be half the difference of the intercepted arcs. See, look where the chords or the secants end up, G and A. So that's 100. Subtract the other part of the chord, the one closer to the angle, is 30. So it's, I'm sorry, I wrote that on the wrong one. 1/2 100 minus 30. Let me take that off. Okay. Okay, 100 minus 30, if you take half of that, that'd be 70, so half of 70 is 35. So angle 6 would be a 35 degree. Well, let's see, angle 7. Okay, 7 is, I don't know if you remember the theorem that talks about anytime a radius hits a tangent, it's always at a right angle. So a tangent with a diameter or a tangent with a radius will always be a right angle. So that's a 90 degree. Angle 8, let's see, 8 would be This one, if you look at the one I colored yellow, see how angle 8's made up of that arc? It intercepts that arc, so it's half. 125 divided by 2, let's write that down. 1/2 of that arc. 125, take half of it, that's going to be 62.5. The ones like this take a little bit longer to do because you kind of have to study all the different angles. Let me know if you have trouble with that.